we left off at HTTP responses, and that's where we're going to pick up today. I have to do the music louder. So when the music turns off, that's my cue to get started. I couldn't even hear the music over y'all. So that was corn. So HTTP responses, we talked about requests, the structure of an HTTP message. That's going to mostly be the same for requests and responses. So let's talk about responses. I'm going to redo a couple slides just so we get our heads back in the game here. But HTTP responses followed a lot of the same structure as an HTTP request with some slight differences. So this response, if you send this response from your server to your client, this is going to display hello in their browser. They're going to see that text hello, and that's all they're going to see. They're not going to see anything else. Yep. Yep. Yes, you do need content type. And I got a few slides. I'll talk about that in a bit more depth. But both of these headers do need to be there. Or more accurately, our new line characters are /r/n. We have to have both of them. So more accurately, this is exactly what you're going to respond with from your server if you want the user to just see the text hello. And I am going to copy this like I did last time, except I should have plenty of time to actually use this response today. So this is what we're going to send. And notice that there is a blank line right here that wasn't a typo on the previous slide. There is a blank line, /r/n, /r/n. You're going to hear me say that so many times this semester you're going to get sick of it. Or CRLF, that rolls off the tongue a bit better. Sometimes I'll call it that. But this blank line, this is actually a blank line. There's a /r/n, /r/n, and then the word hello. And worth noting, we'll talk about it, but no /r/n after hello at the end of the response, no blank line, nothing. But this does have to be here. And dividing each header, of course. We have all our /r/n's. One of the common mistakes, not so much these days because I talk about it so much in lecture now that it's hard to miss, but common mistake is leaving off the /r's and just doing /n and wondering why the browser completely has no idea what the response is. Yeah.
Is the space with the 200 and the OK required?
Yeah, this space right here?
Yeah.
Sure. Oh no, you can't even find it. Yeah, no problem. So what are the differences between requests and... Oh, sorry. So at the request had the /r/n at the end. That was because the request didn't have what's called the body. So this has headers and a body. /r/n, that new line character, that's the cutoff between the headers and the body. So since the body was blank for the requests, that blank line said, hey, the headers are done, and by the way, there's no body to this thing. But now we do have a body, so that separator is more important because we have to, well, it's always important. But the separator is needed to say this is where the characters for the body start. So the first line is a little bit different structure. The rest of the structure is actually the same for requests and responses. Well, that kind of contradicts a little what I just said, but requests can have content. It can have a body. We haven't seen that yet because we've only seen GET requests, but once we start seeing what's called POST requests, when the client sends us information, it'll follow the same structure: content type, content length, blank line, and then body. So the rest of it, aside from the first line, same structure for requests and response. Just convenient. That's like half the stuff we have to learn. So let's talk about the differences. The status line. I always want to call it the response line. Why is it not called? It's the request line on requests, but not the response line on responses. It's the status line. It always trips me up. But if I call it the request line, I don't know. I think that's what it should be called. Or the response line. So the response line, I'm calling it that, is a little bit different structure. For a request, recall that it was the, hold on, I have to recall. The method type, so in our example, it was get, and then a space, and then the path, which if it's just the root path, it'll be slash, but it could be slash static images, slash slides, or whatever. And then space, and then the HTTP version was last. For a response, a little bit different order. We have the HTTP version first, then a space, then the response code. This is a machine-readable code, and the browser is going to take that code to know what happened, like what this response even is. 200 means everything went great. And then a space, and then a human-readable phrase that's a phrase explaining what the response code means to us humans who don't memorize every single response code. Though a good handful of them you'll end up memorizing the more you do web development, but not all of them. So we have the human-readable phrase as well. So 200 means everything went great, or to us humans, okay. Everything went okay. So that's the structure of a response line or status line. So there's two spaces that are very important here. These spaces do have to be here because what the browser is going to do is take your first line, everything before the first /r/n, and everything before the first space it knows is the HTTP version. Everything between the first and second space is the response code, and everything after the second space is going to be the reason phrase, which is the reason why the phrase is the last thing, because the reason phrase, I was very careful when I saying that, the reason phrase can contain spaces. So everything after the second space is the reason phrase, which can have spaces in it. So it's one thing where spaces are allowed, and they kind of have meaning, but not parsing meaning. They have human readable meaning. So that's the status line. The rest is the same as, my response codes. So response codes, I'm not going to go through tons of response codes. We'll learn them as needed. But in general, response code goes in these 100 levels. I should have 100 level on here too, but the 200 level means everything went great. Here's your content. This is the most common thing that you'll see on the internet, and more accurately, you won't actually see it unless you're a developer because you're just seeing the web page that you requested. You're seeing the content that you asked for. You're going to get 200 okay, everything went great. 300 levels, these are redirects. So if a page moved or just for whatever reason a website's sending you to a different URL than the one you requested, it's going to be a 300 response and they're going to send you somewhere else. And that's usually automatic by the browser. Sometimes you'll see a message that says redirecting you, and then you'll go to a different page. 400 level, this means something went wrong and it was the client's fault. 500 level, something went wrong and it's the server's fault. Bless you. And then everything else other than that first line, it will follow the same structure as requests, as I mentioned. But we do have some new stuff here because this is our first request or response, our first HTTP message that has content to it. It actually has a body down here, this actual content that says hello. This can be true for requests as well. So all this will apply to requests when we start getting those post requests in homework 2. But we're going to be on the sending side of this format right now. So whenever we have content, and if we're responding to a user, 99% of the time we're going to have content to send them. There are some responses where we're going to say, thanks for your response, but here's nothing. Here's no information in return. That happens sometimes, but most of the time we're responding with whatever the user requested. If they requested our HTML, here's our HTML. If they're saying, hi, we're going to say hello. This, of course, isn't super useful. It's just the hello world of HTTP. If they request our CSS, we're going to send the CSS. If they request a picture of a kitten, we're going to send them a picture of a kitten in the body. So to do this, we're going to have two very specific headers that we have to fill out, that we have to send in our responses, content type and content length. Content type is going to be how the content should be interpreted, how the bytes of the body should be interpreted. I just want this to be plain text, so text/plain is going to be the content type of this. Since I'm just sending raw text, it's not HTML, it's not CSS, it's not an image, just plain old text. And then content length. Content length is the number of bytes in the body of this message. the number of bytes. So after this blank line, how many bytes are there? This is a very important number, and it has to be exact. If it's not exact, things break. So this has to be exactly the number of bytes in the body of your message. And then what the browser is going to do, and in homework 2, what you'll start doing, is you're going to look for this blank line, and then after that blank line, you're going to read content length number of bytes. Browser's going to read exactly that many bytes. So guess what happens if you send hello and you have a content length of 4 when you're sending 5 bytes? That O, well, that's a bad example, but the O is not going to be there. You're not going to get what you want displayed to the users. If that content length is 6 and you're sending 5 bytes, guess what the browser's going to do? It's going to sit there and wait for that 6th byte. If you have your browser hanging, you send a request and the browser just sits there loading. One of the first things I check in office hours, well, the first thing I check in office hours is your content length. If your content length is greater than the number of bytes that you sent, the browser's going to sit there waiting for the rest of that content because it's waiting to read that many bytes exactly. If it doesn't get that many bytes, it's going to think, and then eventually a lot of browsers time out and just display whatever bytes it did get, and then you'll see your content. So if your page takes forever to load, that's what you should be looking at, your content length. If your content length is lower than the number of bytes you're sending, your whole message isn't going to be read. Yeah?
So if you're sending an image, you'd be sending like a byte representation of the image? Like, so you have to count bytes?
Yeah. Mm-hmm. Which actually is pretty easy. I'll mention that at the end here. But sending an image, it's the number of bytes, but when you read the file, hit it with a len, give me the length of this, and that's your length. That's your content length. Because you're reading the file you're going to read it as bytes, put the bytes here, and then the length of that byte array goes there. I was trying to remember off the top of my head what 100-level codes are. I'm pretty sure there are, but I don't know why I'm blanking. I forget what they are. We'll use 101 switching protocols, but I don't know what the general term for 100-level codes are. Maybe it's only switching protocols. Maybe that's all it's used for. That's all I've used it for. When does Homework 1 autograder come out? Never. There's no autograding in this course. You're at I think at a 300-400 level, you need to be able to test your own code and be confident that it's going to work when you submit it. So no autograding. We might have some scripts that we use on the grading side just to speed up the grading process, but I don't intend to release those scripts. Sometimes in lectures, I do have a few lectures planned where I'm going to show you how to test your own stuff, but that won't be available in AutoLab. 300-level course, like by the time you graduate, you have to be able to do that. Like there won't be AutoLab on your job. So you need those skills eventually. We need to start weaning you off of AutoLab. I know some higher level courses do have autograders, and it annoys me that they do, but you need to be able to test your own stuff at this point. So never. It'll just be manually graded after the deadline. That said, I might have some small portions that are auto-graded, but I don't know. I'm hesitant to even do that. Because if you, there's so much open-endedness in the homework assignments that you can have absolutely correct, properly functioning code for your server, but fail the auto-grader. Like that's going to happen a lot because there's so much flexibility and so much unique code that you're going to write. That can happen a lot. So those situations I'm not fond of. Then that you got extra stress because the autograder's failing, and I'm like, well, let's just see what the TAs say when they grade. Maybe it's fine. That's stress. So I don't intend to do much, if any, auto grading ever in this course. So 100 level content length. I think that was. Oh yeah. I'm like, I know I was about to say something. So you need this blank line here. The reason you need that blank line is because that's the indicator of here's the end of the headers. And the browser and you eventually, when we have post requests, are going to look for that and put a lot of meaning into this blank line. There's no blank line in the middle of the headers. You're never going to have a blank line until it's signifying this is the end of the headers. So what the browser is going to do, it's going to read your requests. It's going to look for the exact byte sequence /r/n/r/n, And everything before that byte sequence is the headers. It's going to parse the headers and read content type and content length to figure out how many bytes to read after that blank line and how to interpret those bytes. So that's why we don't need a blank line at the end of the content itself, is because we already know exactly when to end. We know when the content ends, exactly 5 bytes after this blank line. So there's no need for an extra blank line there. But even if there is no content, that blank line at the end of a request is still needed, because that says to our server, hey, there's no content to this. Look for that /r/n/r/n. Everything before that's the headers. You don't know anything about the request until you do that. So you have to have that blank line, or else all of our parsers are going to break, because that's what your parser should do, is look for that blank line. That's what the browsers are doing, is looking for that blank line. Has to be there on every request, every response ever. But we don't need another one after that, because once we read the headers, now we know everything we need to know about this request or response, and then you can handle it that way. So no blank line at the end, but there must be a blank line after your last header. Oh, sorry, slide. I got ahead of my slide there. That happens a lot. So that blank line is very important. Do not forget that. If you forget that blank line, everything's going to break. If you'd put, for example, just /r/n here and not a second one, and then go to hello, browser's going to treat that hello as a header. It's going to hang. Everything's going to break, because it never finds that blank line. It's going to keep expecting more bytes from your server that it's never going to get, and it's never going to read a blank line. Question?
I was just going to ask what happens if you don't.
Yeah, it's just going to hang. Your browser will never load. You'll see the loading icon in the top, and nothing will happen. Then finally, the content itself. So the number of bytes here has to match your content length. The type of this should match your content type. And if everything's working exactly the way it should, the user's going to be staring at the word hello. And not found, this is one of your objectives, part of one of your objectives on the homework. So if you want to respond with a not found page, and you've seen these surfing the internet, you see these all the time. Respond with a 404 not found. You can have spaces in the reason phrase. Here's a good example, not space found. Space is allowed there. And then when you send a not found, you're going to send an actual message. It could be, if you go to a web page, it could be a whole HTML page. If you want to build a whole HTML page for your 404 on your homework, knock yourself out. Go for it. I'm just going to send text for this, and it's only text required for your homework. But I'm going to send some message that says, hey, you got 404'd with content length, content type matching my message type. And it's going to display a 404 to the user. And in the browser, it'll show up as a 404 error. Yeah?
Is there a maximum message size you could send?
Is there a maximum message size you can send? I don't think so. Snap just want to say no. But there might be like some ridiculously large, I don't know. But there's no practical limit to the number here. There is a limit to the size of the headers, the total size of all the headers, which is on the order of like a couple K. So you do have to be careful with your headers. Don't put ridiculous amounts of information there. But the body, we can stuff all kinds of information there. All right, and we will get to do, I want to make sure I do a demo here. As long as PyCharm will open, come on. It did go to a different desktop. I was trying to get it to not do that. Okay, so here's the homework handout, which, if you haven't seen it before, it's the homework handout. When you clone the start of the homework, this is exactly what you're going to get, is this code. And here's the server. I want to talk about the server because we haven't seen this yet. And I'm going to take, did I really mess up my format? I missed a blank line on the handout code. I want to go through this a little bit. What I'm going to do first is just run the thing and show you what this actually does. So what this does is runs a TCP server running on port 8080 on localhost. So if you run this server and you go to the URL, it's going to be hard to see what I'm typing, but localhost colon 8080. So localhost port 8080, it's going to say page isn't working because I haven't done the homework. This is just the handout code. But if we go back to our code, what we're going to see is we got an HTTP request printed to the screen. This is what my browser is sending to my server when I send an HTTP request. I'm going to have the request line. This is a GET request for the root path. It's just slash. I typed localhost 8080. I didn't do slash content slash static images. I didn't do any path. So the path is the root path, just slash. HTTP 1.1, we expect to see that everywhere, every request. /r/n, so this is going to be the first header, host, localhost 8080, the next header, and then a series of headers until we finally get to the last header and get our blank line indicating this is the end of the headers. And there's no more information here, which I expect because it's a GET request. So this is exactly what the server is going to see when you send a request. Well, not exactly this. This is my browser and everything. Yours is going to be slightly different. But that's what I'm getting when I get the message. So let's pick this question. Yeah. So this is another way of saying localhost, but this way works with Docker. And if I put localhost here, it would still run the example that I just did, but it won't run inside Docker. So I got the zeros just to make it work with Docker. Yeah.
So in the request that you got at the bottom for the cookie, it was saying PyCharm. I'm assuming because you're using PyCharm.
Mm-hmm.
I'm using Visual Studio, but it keeps saying PHP store for me. Do you know what might be the reason for that?
It's some cookie that was set by something. When you're using, the short answer is no, but it could be a multitude of different things. Like when I'm using localhost 8080, any app that I ever ran and tested on 8080, any cookies that I've ever set could still be sitting there. And then PyCharm, as you said, could be set in its own. Like visits equals 12. Like that's something, me doing the 312 homework probably last semester, that cookie's just still there. Auth token, no, this is actually mine too. And then, yeah, the PyCharm one, I guess PyCharm added a header there. That might have also been from a different project I was using, that it happened to set that. Because I don't think PyCharm always sets a cookie like that.
But that doesn't matter when you actually test the cookie, right?
As long as your code works, it's fine. Your code should work.
Earlier.
Oh, yeah, that's probably a separate thing. Then when we're testing cookies, the TAs know to wipe all their cookies before, like they won't have all these residual ones, because that causes lots of issues during grading. They'll wipe all the cookies and then make a fresh request. Yep. So let's go through this code and talk about what it's doing. Host import, we kind of covered there. Allow reuse. This is a line that is awesome to have. When I finally figured out it existed. Now I put it in the starter code so you all have it without having to think about it at all. The port won't always be released. Like when you restart your server, the port won't be released back to the OS right away. And then you'll have port already in use, port 8080 already in use. And you'll say, who the hell's using port 8080? Well, it's you, because your last instance of your program is still using it and didn't release it. If you do allow reuse address, you won't have that issue. You can just restart your server, and it should work. I feel like it sometimes doesn't, but it should work. This is going to start your TCP server. I'm using socket server, which is imported way up here. So I'm importing Python's built-in socket server and using that for the TCP server, as the TCP server. So I'm starting new TPC server at this host and port and giving it my TCP handler, which is the class that we define right here. I'll circle back to that one and get back up there. And then, there's nothing else I want to say. And then serve forever means start the server, let the server do its thing. So that's going to listen for TCP connections. And whenever it gets a TCP connection, it's going to create an instance of my TCP handler. And then whenever, and then call the handle method. So it creates an instance of my TCP handler and then calls the handle method. And then my first line of the handle method is this receive 2048. What this will do is when there is information to be read, there's bytes to be read on the TCP socket. When you create a TCP connection, by the way, we call it a TCP socket. It's a socket connection. When we create that, it's going to read up to 2048 bytes from the socket if there's information to be read. If there's no information to be read, it'll sit here and wait until there is information to be read. So this will sit here until, like, I go to my browser and punch in an address. Then you'll get received data, which are the bytes of the that were sent over the TCP socket, which for our purposes will be the bytes of an HTTP request. And in the starter code, I'm printing out the client address just to, I don't know if you'll ever need that this semester, but I am printing it out just to see the information, just so you can see what's happening. The host of the client was 127.0.0.1, which is another alias for localhost, and port 58,455. And if I send another request, I'll see a different port. You'll see different port numbers. But whenever you see the client port, it's going to be some randomish large port number, which is interesting. I don't want to dive too far into it right now, but I'll bring that up again either when we talk about WebSockets or when anyone asks. Too many acronyms, yes. Accurate. Oh, my eyes. When you talk about this server call, is this framework setting that you talked in the first lecture? No, it's not my eyes, it's the wording. Wait, what is this? Is this framework setting that you talked about? When you talk about this server call, I'm not sure I can parse that. If you want to take another shot, I want to answer your question, but I've been lecturing for 2.5 hours. I can't. My brain can't do this right now. I try, but too many acronyms. I do see that as a good thing, actually. The too many acronyms comment. There's a lot in web development, specifically all of computer science and the whole world, really. But web development does crank it up from other computer science stuff. The reason I think it's a good thing, it's an annoying thing, don't get me wrong. But the reason I think it's a good thing is it looks great on your resume. You have so many acronyms just by taking one course. By the end of this course, you're putting in TCP, HTTP, HTTPS, WebSockets, WebRTC, HTML, CSS, JavaScript. I'm sure I'm missing a few of them here, but you get a lot of acronyms on your resume. Someone who doesn't know what they're looking at is going to be really impressed. Any other web developer is going to be like, any other web developer is just going to say that's the regular stuff. JSON, we'll throw that one in there. And then I'm printing the actual data we received. That's the HTTP request. And notice this B right here. This is a byte array or a byte string. It's being printed as a byte string. This is not an actual Python string at this point. If we want to print it as a Python string, I'm going to decode it. Let's restart the server, and hopefully it doesn't say port in use. I'm going to go back to my browser. I'm going to send another request. Oh, I should have rolled this in with my other demo too. And then it's going to be printed as an actual Python string as well. So it's printing the byte string, and then I'm converting it to a regular string, which is going to interpret those new line characters as actual new lines and print it in a more human-readable format. If you want to see it in a human-readable format. Or when you want to parse this as a string, you'll decode it and then start parsing it. And then if we want to send a response, we're going to use this self.request.sendAll. That's going to send information back to the client. And that's how you're going to send your response. So self.request.send all. Do I not get autocomplete on that? I have to type the whole thing. Goodness. And I'm going to paste what I grabbed from the slides a long time ago. So this is the response that I want to send. If I try to send this, it's going to break. It's not going to let me do this. Over the internet, you can only send ones and zeros. It's only bytes, and I'm trying to give it a Python string. That's not going to work out for me. It's not going to happen. So what I have to do is encode this into a byte array and then send the bytes over the internet. So let me restart this server one more time, get back to my browser, and I can see hello. And I guess there's nothing else to see over here because I only printed out the request. But that's our very first hello world basically as a web server. And if I go to the network, let me back up a second. So something that's extremely useful when you're debugging and just working on any web development stuff is the browser console. So if I right-click on the page, it'll be different for each browser. Any Chromium browser, you can usually right-click and go to Inspect Element. That's going to bring up your browser console. And there's all kinds of information and tools. There's a JavaScript debugger built right into every browser. There's so much stuff here. For now, I'm going to go to Network, refresh the page, and I'm going to see the requests that were sent. And I can click on the request. There was this request for localhost 8080. It's a GET request. The response from it was a 200 OK. The request headers, here's all the headers that were sent to the server. And what I'm interested in when I'm debugging are the response headers. What headers did it get from my server? Well, it got content length and content type. Those are the two headers that I set. So cool. It's good that we got those two headers. And we can see the actual response, the content of the message too. So a lot of information here that we can use. You should be using this extensively, seeing all the messages. This is a really invaluable tool when doing any web development. You can see all the HTML stuff too, if you're into that as well. Yeah. Yeah. So when you respond with a 404, you're going to give your 404 message, like, hey, the content isn't here. What you're looking for isn't found. However long that is, that would be your content length. And then the type in that example would be text/plain. Or you could serve some HTML, and you'd have text/HTML, and then however many bytes your HTML takes up. But it would be whatever 404 page you're serving. Yeah. I right-clicked anywhere on the page and went to Inspect Element. Or you can go to Developer up here and go to Developer Tools. If you're using Safari, first don't use Safari. But if you're using Safari, you do have to switch it into developer mode. A Google search will get you show you the procedure how to do it. But you have to go pretty deep into the settings and switch it to developer mode before that's even available to you. There's a lot of just little annoyances with Safari. Is there any significant difference between using .encode and placing B before the string? No. So I could have also, I just wanted to show off the encode method, but alternatively, you can slap a B right here, and that says treat this as a byte string instead of a regular string. This will do the same thing. This will have the same effect. And just to show this, I'll change my content length to 3, restart the server, go back to my page, and guess what? It's only going to read 3 bytes. It's not going to read the whole message. Even though I sent all 5 bytes, it's not reading them. It's going to only send 3. If I have 6 and I'm sending 5 bytes, just to show that this is actually what happens. Oh, of course it's not going to do it. Oh, no, it was just showing the old response. It's not going to work. It got the headers. It's able to parse those headers, but it's waiting for that 6th byte. And some browsers, eventually, it might give up and print my hello It'll just say, hey, I only got 5 bytes. Here's those 5 anyway. But sometimes it won't. It really depends. Get your content length right. Content length has to be right. Yep.
You sent another message with content length of 0 and then like an extra 6 byte. Would that therefore complete that 6 bytes that it's looking for? Or no?
If I send another wait, what was it?
If you send
Bless
another
you.
request where you just change the content length to 0 and then you had a 6th byte.
If I change the content length to 0 and then, no, because it'll take like the first byte of the headers, or the response line actually, and that'll be its 6th byte. But it's also initiating a new request, so it might give up on the last one. But if I sent like 2 responses back to back, the first byte of the next response is going to be treated as that 6th byte, which will be the H in HTTP 1.1. But yeah, but it's just waiting, and looks like Opera will not render this at all. Things will break. When you don't follow the protocols, things break as they should. They should break. Follow the protocols. Which is common. I say that tongue-in-cheek, but if something is giving you really weird behavior, 9 times out of 10 in this class, or even 99 out of 100, you didn't follow the protocol exactly, so there's something wrong with the way you coded it, and you hacked and hacked and hacked until it worked in your exact environment, in your dev environment. You finally got it working. But if you're just kind of hacking your way around the protocol, when you go to submit, it's not going to work for the TAs in most cases. But if you follow the protocol, exactly, and stick to that, it's going to work everywhere, every browser, any settings, any TA. Everything's going to work. Any machine, any device, any country. It's just going to work if you're following the protocols. Make sure you have the protocols exactly. If you ever come to office hours and say it works in Chrome but not Firefox, well, I know you didn't follow the protocol, and it's just a matter of finding out where the mistake is and helping you find that issue and resolving it. But there's something where you didn't follow the protocol. Brave browser greater than Safari. I tried Brave one time. I think I tried it like right when it came out, and I didn't like it. I'm sure it's improved since then. But better than Safari. Sorry, I read that wrong. I read that as better than Opera. Yeah, anything's better than Safari. Safari's the new Internet Explorer. Like, because even Edge is just a Chromium browser now. For those of you who don't know, Chrome is based on Chromium. So Google made Chromium, which is like the foundation of a browser, and then they extended it and made Chrome, which has a few features on top of Chromium. But they open sourced Chromium. So Opera and Edge are Chromium-based browsers. They just use Chromium, so it's basically Chrome. And then Firefox is its own thing from the ground up. But Firefox is pretty good. Firefox is pretty solid. They've been around forever. They've got things figured out. But Safari is the one mainstream browser anyway that is doing its own thing and hasn't really figured things out yet. And Apple, I like Apple products. I'm not going to skirt around that. But they do like to do their own thing sometimes, and following protocols really isn't in the DNA of that company. So I'm not surprised that they have all kinds of issues. If you like Safari, stick with it and everything. But as a developer, Safari is going to be a pain in your ass because they don't play by the same rules. They do their own things. And even Firefox, there are a few things where I think they don't have it implemented quite exactly to the protocol. But Chrome seems to be doing a pretty good job of that. Chromium follows it. All right. TS web browser. Why doesn't sending 2 text responses work? Only the first response appear. So it's request response. If you go to request, you only send 1 response. If you're sending 2 responses, the browser's going to ignore the second one because it didn't send a request. It got the first response. It read the headers. It read content length number of bytes after that. And it's not going to read anything else. No matter what's sitting on that TCP socket waiting to be read, it's going to ignore it until it sends another request. Then it'll expect a response. Okay, encodings and stuff. Let's talk about this. And I kind of mentioned it in the demo because I knew I was about to do this slide. But the internet can only send ones and zeros. That's it. High voltage, low voltage, light or dark, or Wi-Fi, different wavelengths and stuff. I don't know how Wi-Fi works. It's magic. But ones and zeros, that's all we can send. That's it. So how do we do anything over the internet if everything has to be ones and zeros and we're going to send bytes all the time? Everything is in, it's ones and zeros, so it's bits. But in our code, we treat them as bytes. When we read from the socket, it's a byte array. When we send to the socket, it's going to be a byte array. So we take our ones and zeros and clump them into eights because we're computer scientists. That's what we do. But how are we going to work with these bytes and make sense of them? So first, let's talk about the simplest thing we already did in the demo. Just sending hello. Even just sending hello is challenging. How do we send text over the internet? How do I send the character A over the internet when I can only use ones and zeros? How do we do that? Which is, I assume, an answer that most of you have come across at some point in your lives by now. But we're going to use, rephrase that. We can use ASCII. This is a solution that we have. We can use ASCII. This is a character encoding. What we're going to do is map all of our characters to numbers. We're going to represent those numbers in binary, and then we're going to send those bytes over the internet. The receiver is going to take those bytes. It's going to use ASCII to decode them and turn those numbers back into characters, use those to form strings, and then, bam, we got text over the internet. Fairly simple solution. We're just going to map every character to a number. ASCII uses a 7-bit encoding, and it looks like this. So every character you want to send, if I want to send the character capital T, that's the number 84. In hex, that's going to be 54. So I got to convert, or not 54, but 54. We're going to convert 54 into binary, send those bits over the internet as 2 bytes. And then the receiver is going to read those, as 1 byte. And the receiver is going to treat that 1 byte as capital T because we both agreed that we're going to speak ASCII. So that's how we're going to send text over the internet. So hello isn't actually HELLO, it's 72 in decimal. I'm not going to point them all out, but 101 for E, 108, 108, 101. I guess I am going to do them all. To say hello over the internet, we're going to send those numbers as bytes. That's how we're going to send text. Very straightforward, I hope. That some I kind of assume that most of you, if not all, have come across at some point. You've heard of ASCII, I would guess. But if not, that's ASCII. It's not too complicated. Each character maps to a letter. So hello is going to be this when it's sent over the internet. This is how we're actually going to send that message. This is what flies through the copper and fiber and through the Wi-Fi. This bit sequence, this byte sequence, that's what's actually being sent. Then the receiver gets that byte sequence. We agreed that we're going to speak ASCII, so it's going to look up those characters in the same chart and figure out what letters these represent, or what characters. They don't have to be letters. And actually, one thing I do want to point out since we're here. Carriage return is 13, or a hex D. And then new line, or line feed, CRLF, is 10, or a hex A. So if you see DA, that's going to be, if you're printing things out in hex, that's going to be your byte sequence for that blank line that indicates the end of the headers. Which will be much more important later in the semester when you're parsing post requests. But I wanted to point that out since I had the chart up. Ooh, what's the difference between UTF-8 and ASCII? I like that question. But I'm not going to answer it yet. So HTTP headers can only contain ASCII characters. This includes the request line and the response line. Only ASCII characters in HTTP headers. So everything before that first CRLF, that blank line, has to be ASCII characters. So when I say we agree to speak ASCII, well, the HTTP protocol forces us to agree to use ASCII for the headers. So when you get the headers, you know you can use ASCII. and it's going to decode properly because ASCII's required. It's just required. Can't use anything but ASCII in HTTP headers. That's the protocol. So when we're reading HTTP headers, we can assume ASCII. We can decode that as ASCII text, and then the body might be encoded using any encoding ever imaginable. So the body we can't make any assumptions with, but the headers, ASCII only. It's in the HTTP, it's in the RFC, it says ASCII only. Sorry, bro, it's ASCII only. And that's so we can write parsers, because when we first get a request or a response, we don't know anything about it. So that's the one assumption we can make up front, is the first characters up until the first CRLF is going to be ASCII, so we can parse that and then figure out what we're even looking at. If we didn't have that, what would be step one? We'd have to have some way of telling what the message is even saying. So ASCII, only for headers. We can only use ASCII for headers. And ASCII is a 7-bit encoding, meaning we have 128 characters that we can encode, which is fine for English. Even with English, it has its limitations. But for any language with a different alphabet, this is completely useless. ASCII is not useful at all. Can't really be used. And with the internet, bringing the whole world together, and because we like to use emojis too, that is not encoded in ASCII, we can't do any of that stuff with ASCII only. So ASCII is really outdated. HTTP is a pretty old protocol. When they wrote the protocol, they said ASCII only. We're stuck with that. But it's really an old protocol. We need something better. So let's get more bits. UTF-8 is going to be is really the protocol of the world these days to be able to encode text. With this UTF-8, we can use up to 4 bytes to represent a single character. So if we want more languages, more alphabets, we can use up to 4 bytes, which is enough to store every alphabet, every character, including emojis. They're part of UTF-8. In one encoding in just UTF-8, including languages where every word has its own symbol, it all fits in here. It all fits in 8 bytes. One standard to rule them all, UTF-8 has got us covered, that we can represent any characters that we want with these things. And the real beauty of UTF-8 is the way it's encoded is the first byte of a character. If that first byte starts with a 0, the next 7 bits are exactly ASCII, meaning every single ASCII character is a valid UTF-8 character. So it's completely backwards compatible with ASCII. So we can just use UTF-8, and if the headers happen to be ASCII only, well, it still works with our UTF-8 decoders. So perfectly fine there. And then if we need more bytes, the first byte will start with a number of 1s equal to the number of bytes that are being used. And then each continuation byte will start with 1, 0. This gives us a few nice properties. Only no character is a subsequence of another character, which really reduces the decoding errors. And I think that's the only thing. The one thing to keep in mind with this that I'll say like 100 times is, say you have something like an image and you have the bytes of an image, it's not going to be valid UTF-8 because it's not going to follow this encoding structure. So if you have something that's not UTF-8, it's not going to be able to decode as UTF-8.